Bismillah ar-Rahman ar-Rahim. This June 2022, 32 variant, question number 8. So first we do partial fraction. So have a look. X to power 2 by plus 9x over 3x minus 1, x to power plus 3. And equals to, because of the linear, so I write a over 3x minus 1. Because the power 2 is called quadratic. So whenever quadratic comes, student, we always write never single variable like that. Bx plus c. Now after this, left-hand side, whatever, multiply whole equation. So multiply by left-hand side denominator, whatever we have. Okay. When I multiply with here, it's fully cancelled, and I will get what's in the upper part left behind. X square plus 9x. When I multiply with this cancel with that, this will stay behind with a. And a times 2x to power 2 plus 3. And when this multiplies here, this cancel with that, so this will stay behind of this, beside of it. So some student do one mistake, they write bx plus c into 3x minus 1. Wrong. Why technically wrong? Because it looks like c is multiplying with that. We must put in bracket. After this, what to do? I will plug in this part equals to 0. Look, I'm showing you. So 1 goes there, 3 divide. I will find x value 1 over 3. I'm saying here, put x value 1 over 3. So 1 over 3. So when I put 1 over 3 in a whole equation, then I get what, students? So I will plug in here, here, here. No need to plug in here. Why? Because I have taken this equal to 0. So this will finish automatically. So 1 by 3 square means 9, and plus 9 divided by 3, I get left-hand side 28 by 9. When I plug in 1 by 3 here, so 1 divided by 9 plus 3, I got 28 by 9 times 2a. And there's no need to plug in here or here, because this is 0, I said before. Even I plug in it here, it will give you 0. So ultimately, this will go there and cancel, and a value is becoming 1. So alhamdulillah rabbil alameen. So first I kept this equal to 0. Now I'm trying to keeping this equal to 0. But it will not work. Why it will not work? Let me tell you, when power 2 comes, 3 goes there negative. When I take a root of this undefined, so I will put any other number except this number. So ideal number is 0. So when I put 0 here, 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 and every x value, so left-hand side, I get 0. When I plug in 0 here, 3 times 2a left 3a. When I plug in 0 here and 0 here, so c times to 1, so negative c. So now this a value will come here. So alhamdulillah rabbil alameen. So 3 minus c, and c value becomes 3. Alhamdulillah. Now question comes in our mind, sir, what a or b we got? Why not b getting? So I can put any other number. Okay, I can plug in any, even I can put x is equal to 1 or 100 or 1,000, no problem at all. So okay, so I will plug in this 1 here. When I plug in 1 here, I get a 1 plus 9, it becomes 10, because here 10. Okay, wait a minute. So I get 10. When I plug in here, I get 10. 10, yeah, no. 1 square, 1 plus this becomes 4a. 4a. And when I plug in 1 here, I get a b plus c. When I plug in 1 here, I get here 2. Now I plug in a value and c value in equation. Let's see what happens then. A value 1 and b value unknown, c value is 3. So let's see what happens then. 4 was a 4. Okay, wait a minute. This value is 2 outside. I got 2b and 2 is a 6. And I got 10 equal to 10 plus 2b. Ultimately, b becomes 0. Okay, I plug in all 3 values back in equation. Which equation I'm going to plug in? I'm going to plug in this equation. So this equation I'm going to copy and I'm going to paste here. So when I come paste here, and now I replace the values. A value and B value and C. A value is 1, B value is 0. So 0 and C value is 3. So Alhamdulillah Rabbil Alameen, this part is done. And now I'm going for the next part. So part number 2, we have to do what? We have to find integration of this 1 to 3. Okay, dfx. So this whole equation, I'm going to copy from here. I think better to copy this part only. This part only. Because this answer is of this, okay. So I am writing it here this way and dx. So let's start, students. So let's see how we can continue. Here we have two properties are very important. One is that the function down, derivative up. What is differentiation of 3x is 3, 1 becomes 0, so 3 was a 3. This 3 we can produce up, no problem at all. What is method to producing? 3 multiply, 3 divide. Upper 3 will go out inside, the lower 3 will stay outside. So look, student, this rule is very, very clear. You know it very well. Function down, derivative up, the power of whole function is 1. So we can say it is a logarithm of function. So we can say logarithm of function 3x minus 1, limit 1 to 3. And this, all of this whole thing eliminates automatically. Even this 3 eliminate, but this 1 by 3 will stay outside. So this is okay. Because basically we have a formula, what for it? Function in denominator, its derivative in the numerator, and the power of 1. So logarithm of function, which is in denominator. This is a rule, we have done it. Okay. So Alhamdulillah Rabbil Alameen, I think okay. So let's talk about a second thing. Second thing is that what is this derivative 2x? What is this derivative plus 3? Problem is that constant can be done inside, outside, but variable we can't produce. Do we have x available on the top? Answer is no. Problem is that we can produce the number like this I produce, but can I produce x up? No, x I can't produce. So in this kind of question, we don't have it, we have a special technique. And what is that technique? So a square plus x square 1 dx. This formula is applicable, and answer is 1 over a tan inverse x by a plus c. Repeat. 3 rules are there to implement. Rule number 1, separate squares. Separate squares. Separate squares. Number 2, positive sign in the middle. Positive sign in the middle. Third rule, the x square coefficient must be 1. So x square coefficient is 1. These 3 rules I must implement. So let's start. I can go to split them. First of all, this 3 will go out like this. 1 to 3. I have done this much done. Alhamdulillah Rabbil Alameen. Ask yourself, do we have this square available? No, here available, here not available. So what I can do it, this 3 I can write what? A special format I can write. Okay, what is that format? Hold on, I tell you. So I can write 3, but because I need a square of both values, I write root 3. Because student, you know, root 3 square will cancel, give you 3. So it means this 3 you write this way, no problem at all. Now, look, student, I have this, read the rules now. Rule number 1, separate squares, yes. Rule number 2, positive sign in the middle, yes. Rule number 3, coefficient of x square 1. And see what is here? Nothing. So 1. So all 3 rules fulfill. And how to integrate? So 1 over constant, so I mean root 3, into tan inverse variable over constant. I think you got my point. A limit is very clear. This value you could keep inside, you keep outside of the limit, no issue at all. 1 over 3. Now plug in this 3 through the 9 minus 1, 8. So log of 8 minus, plug in 1 here, I get ln 2. Let me recheck. So first of all, plug in 3 is a 9, 9 minus 1 is 8. Correct. When I plug in 1 here, 3 minus 1, 2. So this is done, but I can do further. Due to negative sign, 8 and 2 divide. So 1 over 3 log of 4, because it's simplest form. 2 1s are 2, 2 4s are 8. Done. All right, so let's go for this part. 3 over root 3, I have already attained. So when I plug in 3 here, students, so what happens, student? Look at here. So 10 inverse 3 over root 3 minus, plug in 1 here, 10 inverse 1 over root 3. Okay, now when you type in calculator here, the typing in calculator 1 by 1. So when you type in calculator, make sure it convert your calculator in radian mode. So when I type it, this answer is coming with a pi by 3, pi by 3. And when I type the other one, this one, okay, students, so tan inverse. So it is giving us pi by 6. Okay, pi by 6. Let me recheck. Yes, exactly correct. So then I can complete it how? So naturally, this is at LCM, and 6 and 6 LCM is 6. So 3, so got a 2 pi minus pi. And finally, I can see here 1 over 3 logarithm of 4, 3 root of 3 into pi by 6. 3 ones are 3 twos are. So I can see here 1 over 3 log of 4 plus pi over 2 root of 3. Yes, 2 root of 3 exactly. And this is our final answer. I believe you got a point.